This is lecture 12.2. We're going to continue to discuss objects, and in this lecture we're going to be introducing the idea of inheritance, as well as discussing the static keyword. Let's start with a quick review of the last few lectures. So first of all, this is a mini exercise, so pause the video and see if you can fill in each of these blanks. Okay, so first of all, we can define a blank that defines a new type. Class. So if we're going to declare a new type of type object, then this is going to be a class. If we declare variables of that type through blank, creates an object or an instance of the class. Instantiation. If we create an object of a specific type, we are instantiating that object. So if we create a string variable and give it some object, then we are instantiating a string. The class can define fields known as blank and methods known as blank. Fields are known as instance variables. Methods are known as instance methods. Each object has its own blank of the fields and methods. That's why they're called instance variables and methods. Each one has its own copy. Let's go again. Pause the video, see if you can fill in the blanks. Okay, methods must be called on an object, which becomes the blank for the method. So the example would be myStudent.toString. So what is myStudent in that case? It is the implicit parameter. We use blank to access the implicit parameter in its own class for readability and clarity. So anytime you want to declare, or anytime you want to refer explicitly to the implicit parameter, we use the this keyword. Methods can access the object's fields by referencing the field names. However, we typically make the fields blank to the client. Instead, we provide access to these variables using getSet methods. This is called blank. The first one, we typically make the fields private, and then we'll call using get and set methods and preventing direct access to the instance variables encapsulation. Blank are special methods that initialize the object when it's created via a new operation. We often create multiple constructors. This is known as blank. So the first is obviously constructors, and the second is overloading. A blank method is usually written to create a printable representation of an object. ToString. Since it has the same number and type of parameters, we call this, remember, overloading is when we have multiple methods with the same name, but different sets of parameters. So either a different number of parameters or different types of parameters. However, if we are defining our own ToString or constructor or equals methods, then we are overriding. Now let's talk about the static keyword. So most of the methods that we defined in the early portion of the class before we started dealing with objects were defined as static. So a static member of a class is going to reside in the class rather than as part of an object. So let's understand what that means. When we are dealing with an instance variable or an instance method, we said that each instance of the object, so S1 is an instance of student, S2 is an instance of student, S1 and S2 each have their own copies of age, name, GPA, and they each have their own copies of get GPA, set GPA, and the rest of the instance methods. However, if you declare a method or a variable, or a field, I should say, in the class to be static, then it doesn't have a copy in each of the individual instances. Rather, there only exists one copy. There's only one if it's declared as static, and it resides in the class, not in the object instance. And you can have both static methods and static fields, which will reside in the class, not in the object instance. So unlike instance variables and methods, static methods and variables are shared. There's only one, and it exists at the class, and it's shared with all instances of that type. So if we have some class with static fields A and B and instance fields 1 and 2, as well as static methods C and D, and instance methods 3 and 4, so all the numbers are instance, they're going to have copies inside of each of the instance objects. So inside of S1 and S2, or inside of each of the objects, while A and B are static fields and methods, so they do not have copies inside of each of the objects. They only have one copy in the class. So then in the memory for each of the object instances over here, so each of these is the memory for one object. Inside this memory, we have only the instance variables and instance methods, because all of the static variables, the static fields, and the static methods reside only in the class. They do not reside in the object instances. So then a static variable is going to be a shared field that all of the instance objects can access and modify. Very similar to a class constant, except that its value can be changed, and it can be changed by any of the objects of that type. So to declare a static field, you would say private static type and then name. So type is the data type and name is the name of the private static variable, private static keyword. You can do the same thing and initialize it if you so wish. An example of this would be private static, the type is int, and then item count is the name of the static field, and we're initializing it to 0. Notice that it's set to private, so we could not access it outside of the particular class that it's declared in. However, each of the individual objects of that type would be able to access and read this field. So accessing this inside of the class in which it was defined is straightforward. We would be able to say, here's a local variable called account num, and we're going to set it equal. We're going to assign it the value which is stored in my static field, which is some static field declared in the class. And we can also set the value using a similar statement where we just say my static field assigned the value account num, or is equal to the value account num. So accessing and modifying this value is very easy inside of the class. If we did not choose to make this particular field private and instead allowed it to default to public, then we would be able to access it outside of this method, or outside of any of the objects of this type inside of a client program. So we could declare some client program and refer to the class name and then use the dereferencing dot operator and access the value stored in field name, or modify the value stored in field name. So let's think about when static fields would be useful. First of all, think about a bank account class. And let's say each account is automatically assigned some unique account ID, and we assign them sequentially. So if some customer gets account number 1, then the second customer is going to get account number 2, and so forth. So we can use a static field in type bank account So in the class bank account, we can create a static field that is shared by every object instance of bank account, and we can keep the current count of bank accounts in that static field. So when we created the first bank account, we would create an object of type bank account, and we would increment the value stored in the static field in the bank account class. Then when we created the second bank account, we would increment the value stored in the bank account class and assign that value as the account number for this new account. So the initial account is going to be incremented and assigned the value 1 from 0 to 1. Then when we create a new object of type bank account, we increment the count stored in our static field in the class and assign this number as the account ID for this new object. So then in our constructor, we would just say increment account number of accounts, which is a static field in our class bank account, and then assign that value, which is stored in that static field, to the account ID, which is an instance variable inside of our bank account object instance. You don't always need static fields, but some situations lend themselves very nicely to using static fields. One common use, like we're showing here with the bank account example, is sharing information across multiple objects of a given type. So using a static field to keep track of the number of bank accounts to be able to assign the next bank account ID correctly would look something like this. We'd have a private static integer, and then it's called object count, and we initialize it to 0. And this is going to keep track of how many accounts are created. So it's the number of objects that have been created of type bank account. And then we have our usual instance fields, which are private, but they're not set to static. So these are going to have copies in each of the individual instance objects. And then inside of our bank account constructor, we're going to increment the number of objects, because if we are inside of our constructor, then we're building a new object. So we're going to increment the number of objects, and then we're going to store the value of object count into our instance variable called ID. So now we have a unique identifier for this bank account, and we passed one parameter to the constructor, which is the owner's name, and we'll store that in the instance variable name. Then we can access this ID using the getID method. However, notice we've not supplied a setID method. So since this is set to private and we have not given a setID method, this ID value is permanent. It can't be changed. So now this unique ID has been created and is not changeable from a client program, which is exactly what we want for a bank account ID. We don't want someone to be able to change it erroneously and break our system. So this is properly encapsulated and gives us the functionality we want and allows us to share information between the various objects of type bank account. So now we begin a discussion of this idea of inheritance. First of all, inheritance is going to allow us to define some general class and then be able to define more specialized classes and extend the general class so that this more specialized class takes on all the already defined functionality and the more specialized. So it's a way of declining a general set of information and behaviors and then being able to pass that along to as many more specialized classes as necessary, which may need to make use of that general behavior. So the nice thing about this is once we've programmed and defined our more general class, only the new distinguishing features for a more specialized class need to be defined. This is an important idea in computer science because it allows us to quickly build new classes and base them on existing well-developed and debugged classes. Therefore, we can reduce development time and the time required to test and debug the new class. Let's talk through a simple example. So first, let's say we have some general class called vehicle. And this vehicle class has instance variables built into it for weight and maximum occupancy, along with appropriate accessor and mutator methods for those instance variables. So we have a vehicle class and instance variables weight and maximum occupancy with accessor and mutators. But now we don't just want a vehicle class, we specifically want a specialized class called automobile. Now understand, an automobile is a vehicle, but it has more attributes. It also has, say, number of doors, engine size, and maybe the style. Is it a coupe? Is it a four-door? So we can understand that an automobile is a vehicle with more information and behavior. So then we can inherit all the behavior and information from the vehicle class and extend it to be an automobile by adding what is missing. So let's take another example. Consider a college record-keeping system with records regarding students, faculty, and staff. Students, faculty, and staff are all persons. So they have some things in common, right? Each one is going to have a name. They're going to have a date of birth, gender, home address, government ID, social security number, these various attributes. So rather than setting about trying to code the idea of a student and building the student class, first we can define a general class called person, and then we can define the difference between a person in general and a student, or a person in general and a faculty member. And so therefore we can extend the general person class to each of these more specific situations. So we'll say, for simplicity's sake, that we are going to keep track of the name, but not home address or any of that information for a person, and that our student class is only going to deal with the student ID. So we're not going to deal with all the other GPA and all that information. So we've said that there are things in common between students and employees, in that they're both persons, but we've also said implicitly that they are not the same, right? So there are differences. So for instance, students take classes, employees have salaries. So we can use the concept of inheritance to capture these differences, but be able to use the same generalized basic class called person. So our inheritance tree looks something like this. Students and employees are both persons. Faculty and staff are both employees. Undergraduate and graduate are both students. And master's, doctoral, and non-degree are all graduate students. So student could inherit the data and behaviors, which are a part of the class person, and undergraduate student can inherit the data and behaviors of the class student. So let's discuss what a person class may look like. First of all, we would have some instance variable called name, because we said that the data we were going to keep track of was the name, and it's encapsulated because we have it set to private. Notice it's not static, so each individual instance object is going to get its own name copy. Then we have a default constructor, which is going to initialize name to not known, and then we have a constructor which uses the setName method, the mutator method, to set the instance variable name to whatever is passed as a parameter to the person constructor. And then we have setName, which takes a parameter called name and is going to assign it to the instance variable name, which is accessed using this.name. And then we also have the getName, which is going to return the string which is stored in the instance variable name. Continuing, we have a toString overriding method, which overrides the default toString method, and it's going to return the string name : space and whatever is stored in the instance variable name. And then we also are overriding the equals method, and we're using the syntax that we discussed in the previous lecture, where we are accepting an object parameter called other. We check to see if other is an instance of the class person. If it is, we cast other into a type person and store it in a person reference variable called other person. And then we are going to check to see if the string stored in the instance variable name is equal to this other person's string name. And if this evaluates to true, then these two are equal. So if they have the same name, it's the same person. If this evaluates to false, then this will return false, meaning it's not the same person. And obviously, if the object called other is not of type person, then we know that they are not equal, and we're going to return false. So now we have created a person class to capture the similarities between students, faculty, and staff. But now it's time to think about how are student and faculty and staff different. We've captured the similarities, but now what is unique about a student, what is unique about a faculty member, and what is unique about a staff member? So faculty and staff actually could be split into, or could be combined, and we could look at further similarities because they are both employees. So the group faculty and staff have things in common which they do not have in common with students. So we can create a further class called an employee to capture these similarities, and then we could create the faculty and staff classes, which would be based on the differences between a faculty member and a staff member. So to base a class on some more general class, this is the syntax we would use. Public class, and then this is the new class name, the more specific class name, and then we use the keyword extends, and then the base class name. So for instance, we would say public class student extends person. Or perhaps if we were going to be programming the employees class, we would do public class employee extends person. So let's run through a quick summary to reinforce what we've said. When you define a derived class, which is a class which is going to inherit information from a more general class, you can declare or define the added instance variables, so what you need to add into the instance variables, and or the added or overridden methods. So just like we override the default methods which Java gives to any object, we can also override any of the methods which are a part of a base class. The variables and methods of the base class, which aren't declared private, are inherited automatically to this new derived class. So in our example, all student objects are also people or person objects. So they are going to inherit from the person objects. So they are automatically going to include a name field. And we can still use the setName and getName methods, which are a part of person, because student inherited those methods as well as inheriting the name field. So here's a point to be made. The student class can't directly modify the name even though it inherited it from the base class. So we could not say my stu, which is an object of type student dot name, and set it equal to Snoopy. And the reason is because in the base class, this instance variable is private. So now, when we are writing our student class, we would write it in the following way. Public class student, so that's similar to what we've seen previously, but then we're going to use the extends keyword to say, hey, we want to inherit all of the methods and fields from person. Then we will declare a student ID as a private instance variable. So we're encapsulating the ID, and if we're encapsulating it, we're going to have a get student ID number and potentially a set student ID number. Just depends on how we implement it. So we have to declare any instance variables that we want to add. So not all persons have an ID, but all students have an ID. So we had to declare the student ID as a part of the student class. So this is why we call it extending person, right? So we've added to the idea and concept of a person object, and we've added a student ID as well as other methods. And so now we've extended the idea of a person object to be the idea of a student object. Then we have our student constructor, which is going to use this keyword super, which we'll talk about soon. But the short version is super is a way to refer to the extended class, so the base class. So this is calling the default constructor for person, and then we initialize the ID of this student to 0. And then we have an overloaded constructor, so we have a different set of parameters here. And in this instance, we're calling the super constructor, which is the person, so the super class, and we're giving it name. And then we are setting the ID, which was passed into the student constructor, to into the ID instance variable. So two constructors, one a default constructor, one a constructor with parameters. And in both cases, we're using this super keyword, which we're going to discuss further later. And then we also have student-specific methods. So these are methods that we don't have in the person class, but we are going to add to this student class. So first is called reset, which is going to set the student's name and student ID. So we can pass it the name and ID, and this will reset the student's information. Then we have get student number, which is going to return the ID. So this is an accessor method, while this is a mutator method. Now notice we are using the set name method, which is part of the person object. But we're using the set student number, which would be a part of the student object. It would be the mutator method for the ID instance variable. So person is called the base class or the superclass, sometimes called a parent class, but typically in Java you'll see it referred to as either base class or superclass. So person is the superclass, while student is the subclass or the derived class, because it is considered to be a derived class based on the person superclass. And this is how we talk about one class's data and behaviors being inherited by some other class. We would say that person is a parent superclass or base class to student, which is the derived class or subclass or child class. Typically, we'll use either the nomenclature base class or superclass for person, and either subclass or derived class for student.